reinforcement in both direction, in x direction and y direction, or longitudinal direction and transverse direction. You got it? Okay. We will learn how can we get this reinforcement. Don't worry, we understand right now. Pouring concrete. Remove your formwork. Here is the final shape of your solid slab from bottom. You have slab, you have drop beams supported by columns. You got it? You got it? What is the meaning of solid slab?
You haven't had a break in like forever, so you search for a beach vacation.
They use scaffold to keep the formwork up.
What is that?
Some other type of things, like, they go up to
So
support.
the red looking board?
No, but
Very
I'm ready to fight after
Can you
this.
turn on the light, please?
You ready?
For flat slab,
10 more minutes or what?
for flat slab,
Someone's not eating that way.
if you would like to get your thickness of your flat slab, you can use this equation if you don't have any drop panel, or you have drop panels. Like your friend said, sometimes we are worrying about bunch. So what do you think? Where is the bunch? Where? At column. So do you think I need to increase the thickness for the slab, for the total area?
No.
Just, I have a concern at this location. Maybe I have another option. I will keep the thickness 4 inch, and I will increase only the thickness of your slab at the area of your column. If you did this, that means we have flat slab with something called drop panels. Okay? So this shape called drop panels. Your thickness of slab at this one is the original thickness of your slab and the thickness of the drop panel. Sometimes, if your drop panel is not enough also, you have a huge amount of fluid and you have a concern about bunching, we can do something called capitals. Head of your column. Your column has a head, and after the head of column, we have drop panel. Then we have your original slab. So if your shear, if your bunch is still unsafe, no, change your main system and choose something else. Because nothing after this. You have head of your column, you have drop panel, and you have your original slab, and your shear, your bunch is still unsafe, so we need to change the statical system. Select something else. The original shape of your flat slab, your column supported by slab directly. Sometimes we have drop panels, sometimes we have drop panel and column head. Anyway. According to what is the type of your building, I can figure out what is the value of your live load. For example, if you are talking about bedrooms area, so this area has a live load equal 30 pound per square feet. If you are talking about garage, you can expect trucks or something like this. So your value would be 50 pound per square feet. That makes sense. Bedroom only 30. For garage we have 50. And so based on what is the main purpose of your structure, I can figure out what is the value of life load. Also, I can figure out what is the value of your finishing, ground or floor finishing. So for example, if your finishing is wood flooring, this finishing will cause additional dead load equal 12 pound per square feet. If you are talking about finishing of ceramic tile, so you are talking about 15. So based on what is the type of finishing, I can figure out what is the additional dead load. What is the main purpose of your building? I can figure out what is the value of life load. And remember, we have two main combinations for dead and life. The first one, 1.4 dead load. The second one, 1.4 dead load. I'm sorry, 1.2 dead load plus 1.6 life load. Design of slabs, it's very complicated process. So we are going to use another software called Reza Floor. Starting from the next semester, we will have license for this one, Reza Floor. Reza Floor can solve any kind of floors with beams, columns, and any kind of slab. I will go through this software next time, not today. We have an example, solid slab example, 15 feet, 10 feet, 20 feet. This panel, we have a stairs here. So anybody here can tell me what is the difference between this plan and this plan?
The stairs still in the same location?
No, this plan is architectural plan.
Lower structural.
I will not define this plan to Reza. I'm defining structural floor. I'm defining column. I'm defining beam. I'm defining slab. But this shape cannot tell me where is the beam. This line, not a beam. This line is a wall. You know what I mean? This plan called architectural plan can tell me where is the wall of each room. Cannot tell me where is the beam, where is the slab, all of this stuff. But anybody here know how can I define locations of your columns?
Grid lines?
You said what?
Grid lines?
No. Do you know where is the column? Where? The location of your columns. Columns must be defined
in the columns,
on this plane.
inside the walls.
It will not accept it to define a column here at the intermediate area of your bedroom. It will not be accepted to define column at the intermediate of your living room. Maybe this will happen, but in a very limited situations. So the best scenario to define locations of your column to have architectural design. I prefer to put my columns at corner. We have a wall, we have another wall. At this corner, I can define my column. You got it?
Mhm.
Can you see here? Your column, this green rectangle. No problem with this column. We can accept this column at this corner, but I cannot accept a column at the intermediate area. You know? So we have another column here. Also, spacing between each column. Spacing. What is the importance of spacing?
Wow.
What will be supported by this column? beams or floors. So we have a beam supported here by a column, supported here by a column. If this length, which called L, very long distance, what do you expect for your bending moment? Too much bending moment, too much shear, too much deflection, and economic design. If you have very short distance between your columns, it's not economic also, because very short distance make your beam has a very small deflection, very small bending moment, very small shear, so your design will not be economic. The best distance between columns, something around 10, 15, maximum 30 feet. Anything below 10, not economic. It's correct. To be more specific, it's correct. I cannot say it's wrong, but not economic design. Anything more than 30, that's fine also, but your design will be not economic, because we can expect too much load on one beam. So, if you would like to define location of your beams, keep the architectural design in front of you. Try to put your columns. Once you did, and remove the architectural design, you can find something like this. Locations of your columns. Then, between columns, I can put my beams. Between beams, I can put my slabs. This is the best scenario to define your structural system. Do you have any question for this point? Believe me, these points are more important than how to design, because you are talking about the stability of your building. Once you did your structural system, believe me, anything else will be more easy. Nothing. But the first start is more important. So we have architectural design, put your column. Between columns, I will put my beams. Between beams, you can figure out your slabs. That's all. So we need to define this floor system to your software. Where is your column? We need to define columns. We need to define beams. Your column is 20 times 20. I will assume it. Your beams 16B times 30. Slab thickness 5 inch. Your building is office building for live load. And I would like to design slabs, design beams, design columns, design footing. We learned how to design beams. That's right. We, against bending and shear. We learned how to design columns. We still need to learn how to design slabs using software, how to design footing after exam 2. We'll use software finally to tell us what is the bending moment on your slab as a contour lines, as you see. How can I use these contour lines for slab to design? We will learn next time about this one. And the deflection also. Do you remember, for serviceability, we need to check of deflection to be within the limit. That's all for today. Okay? So if you have a chance next time to get your laptop and download RisaFloor, a demo version, so it will be good. And put it in your mind, we will not have exam for this part, but your project for this course based on RisaFloor, your next semester for capstone project, you will use this software. The student who cover structural design for your project, they will need this topic. Okay.